Okay, so what a Venn diagram can do for us, or what we're going to do with it, let's go with that. We're going to use it to draw information that's represented in the premises. So draw using the premises. And then we're going to use the Venn diagram to confirm the argument is valid. Use Venn diagram to confirm argument is valid. Okay, so we're going to go through some specific examples. All right, all fish live in the water. Whales are not fish. Whales do not live in water. Okay, so let's start by setting up our Venn diagram here. And let's think about our sets. We've got all fish live in water. So we've got one set that would be things in water. And then inside the things that live in water, we have fish. Okay. Let's see. Then where are whales on this? So whales live in the water, but they're not fish. So they've got to be, let's see, well, whales should live in the water. So we'll kind of put an X right there. Okay, so what can we conclude then? Well, the problem is that whales do not live in the water is wrong. They actually do live in the water. So if I know that all fish live in the water, which is what the Venn diagram says, and I know whales are not fish, that just means the X for the whales has got to be outside the fish range. I'm not quite sure where it is, but that is not supported. So this idea that whales don't live in water, there's no evidence to support that. At least we don't have anything directly. In terms of structure and validity. Okay, so let's go through, look at sort of a conditional of if P then Q for all of these. Okay, and we're going to throw on top that P is true. Can we conclude that Q is true? And that's from our truth table analysis from previously. That's actually correct. We can. So this is in fact a valid argument. Simply knowing that P is true, I can know that Q is true. So we call that particular pattern affirming the hypothesis. So what about this? If P then Q, so what if I tell you that Q is true? Okay, can I conclude that P is true? And that's actually not correct. That's an invalid argument. People do it, doesn't make it right. Way back in the beginning, we looked at various things that people try to argue that don't have any value or merit. This is sort of another one of those. This particular pattern is called affirming the conclusion. So when we look at Q being true and you try to imply that P is true, that's actually not a valid argument. And what we've done is we've affirmed the conclusion. Okay, let's see, if P then Q, let's say P is not true, can I conclude that Q is not true? So if I tell you that P is not true, is that safe to say that Q also is not true? And that actually has a problem as well. Simply knowing P is not true does not guarantee whether Q is not true or not. So that's an invalid argument. But again, people try to do that. They try to argue that. So that particular pattern is called denying the hypothesis. And then the last one, Q is not true. Can I conclude that P is not true? Well, if Q is not true, let's see, if P then Q. Well, the only way Q is not true is if P itself is also not true. So that's actually a valid argument. And so that particular pattern is called denying the conclusion. So if you remember when we talked about logically equivalent statements, these four statements are very similar to your conditional, converse, inverse, and contrapositive. So notice the first and the last, affirming the hypothesis and denying the conclusion, have the same truth values. They're connected to each other, just like the conditional and the contrapositive are connected. Whereas the middle two are connected like the converse and inverse are connected to each other. Okay, so let's take a look at a more concrete example, aside from all these P's and Q's I got floating around here. So consider the argument. If a person lives in Chicago, then the person likes windy days. Premise, Carlos lives in Chicago. So can we conclude that Carlos likes windy days? Okay, so we're going to go at this with a Venn diagram. This is a deductive argument, so we're going to use Venn diagrams to assess whether the argument is valid. And so let's kind of think about what our sets are. I need to have a set of people who like windy days, so I'm going back to the premise that if someone is in Chicago, then they like windy days. So there's got to be a set of people who like windy days. Okay, and inside that set are people who live in Chicago. Because we're saying in the premise, I don't have to agree with it, that's just what they're telling me the premise is. So all people who live in Chicago also enjoy windy days. Okay, next premise, Carlos lives in Chicago. So let me put an X where Carlos is. He's in Chicago. Can I also safely conclude that he likes windy days? Well, Chicago is inside the bubble of windy days. Carlos is inside that bubble, so it must be safe to conclude that Carlos likes windy days. So this is a valid argument. Now notice, let me kind of back up. So even though it's valid, using deductive reasoning, I don't have to like it. I personally don't like the statement, if you live in Chicago, you must like windy days. I don't think that's actually true. But given the premise, I have to go with it. It's still valid, even if I don't personally agree with it. Again, my personal opinion does not indicate whether it's true or false. Okay, let's look at another one of these. Okay, if you liked the book, then you'll love the movie. I don't have to agree with that, that's just what I'm told. You did not like the book, therefore you will not like the movie. Well, let's think about what our Venn diagram's got to look like. Okay, so we have a circle. Let's see, draw a nice big set here. So we have one circle, So if you like the book, then you'll love the movie. So this has got to be, the big one is love the movie. And inside this, we have like the book. Okay, so I know you did not like the book. So that means you've got to be outside of like the book. The problem is I'm not told if you're in that part of the picture or that part of the picture. I just know you're outside of the book circle. So that means you got to be either in the love the movie circle or completely outside it. I'm not really given enough information past that point. So this argument is not valid. Or invalid. Because there's not enough information to properly answer that. Okay, a narcotic is habit forming. Aspirin is not habit forming. Aspirin is not a narcotic. Okay, so let's kind of think about a narcotic is habit forming. So let's look at a circle. Let's look at a set and then we'll do a circle of, let's see, a narcotic is habit forming. So that means we got to have a habit forming circle. And inside the habit forming, we got to have a narcotic. So we're saying a narcotic is habit forming. Aspirin is not habit forming. So I know it's not in the habit forming circle. It's got to be outside it. Aspirin is not a narcotic. Okay. Well, if narcotic is inside the habit forming circle and aspirin is outside of that thing, that means I can't be inside the narcotic circle. So that's actually a valid argument.